So hello dear friends, once again welcome. Now let's talk about how to find out degrees of freedom for a robotic structure. Okay, so degrees of freedom, you know the minimum number of variables required to specify the system completely. Okay, so for the 3D cases we know 6 degrees of freedom required, and for 2D 2 degrees of freedom, sorry, 3 degrees of freedom required. Yeah, so means in x, y, and suppose rotation, then theta, and 6 degrees of freedom x, y, z, and rotation about each axis. Okay, means theta x, theta y, theta z. Okay, when the robot becomes redundant. Okay, so if its degrees of freedom increases, if having more than degrees of freedom, having more than 6 degrees of freedom. Okay, and when this situation comes, as we know in the case of industrial manipulator, 5 degrees of freedom are enough, but we will not get the means infinite number of solutions if there will be least number of degrees of freedom. Okay, similarly, if having high degrees of freedom, then more flexibility, more means infinite number of solutions we will have. Okay, so when the situation comes when more than 6 degrees of freedom required, suppose a robot has to follow the path, avoiding the obstacles in between, has to go in the narrow space, avoiding the obstacles. In that case, more flexibility is required. Okay, and when robot becomes underactuated, so definitely when its degrees of freedom is now less than 6, okay, then it becomes underactuated. Okay, so our focus is now how to find out the degrees of freedom. So there is a Grubler's criteria to find out the degrees of freedom, that is f is equal to 3l minus n minus 1 plus summation of I is equal to 1 to n, and here f I. Okay, now what is this? So f is here, f denotes degrees of freedom. What about this? So it is number of links. Okay, and n number of joints. Okay, and this is what fi means. Fi, it is the number of degrees of freedom associated with ith joint. Okay, and suppose a system has the prismatic joints, rotary joints, or hook joint, spherical joints, then we have to sum up all the individual degrees of freedom, like in the case of prismatic or the revolute. So it provides how many degrees of freedom? 1 degree of freedom. How? Okay, so and what about prismatic revolute and spherical or hook joint? Suppose cylindrical So it provides 2 degree of freedom. Okay, and what about spherical? So 3 degree of freedom. It can rotate about all the axis. Okay, and in the cylindrical में क्या आ जाता है? There will be one the prismatic, or better to draw it here. I'm going to like and this is the axis. So rotation about axis, suppose theta here, and the translation along the axis, that is the d here. Okay, and in the case of prismatic, this is the one link, and the joint is here, and another link. So whatever the motion in between, that provides only the 1 degree of freedom. There will be rotation only. Okay, like this one and theta. Okay, and similarly the spherical it is like that. So the schematic आप भी देख सकते हैं, it can rotate about all the axis. That's why 3 degree of freedom. Okay, like our shoulder joint. And what about hook? So hook provides 2 degree of freedom, and how to show it to the schematic. So it can rotate about its own axis, a fixed axis, and it can translate. Just you visualize the hook joint. Now let's take an example of schematic view of planar manipulator, planar serial manipulator. Okay, so what is the meaning of this planar serial manipulator? Planar serial manipulator, or you can say the robot. Okay, so planar means we're talking about 2D. Serial means you can see all the links, how many links are there. So all the links are connected by the joints in a series. That's why serial manipulator. Or you can also say that open kinematic chain. ठीक है, क्योंकि ये जहाँ से स्टार्ट हो रहा है, देखिए एंड इज नॉट कनेक्टेड टू anything, any other mechanism, linkages. Okay, now it is open to interact the environment, to suppose capturing some object. Okay, so this is regarding planar serial manipulator. Okay, now we have to apply. What we have to do? We have to find out the degrees of freedom. Okay, so applying Grubler's criteria, that is F means degree of freedom, that is equal to 3 L minus n minus 1 plus summation of I is equal to 1, then n it goes to n and f I, and then we have to identify the number of links. L means number of links, okay, including fixed base. Okay, and n is what? Then n is number of joints. Okay, so firstly this is the we are talking about the number of links. This is the one link, the base of this robot. Okay, means this is like this. Okay, so it is the base of the robot, base of the robot, and this is serial number 2, 3, 4 and 5. So L is equal to, we have 5. Okay, and what about the number of joints? Okay, so here one joint I, then second revolute joint here, then third again revolute joint, so third number, and before that here third one is the prismatic joint, and the fourth one is revolute joint. Okay, so in this way n is equal to 4. Okay, and what about Fi? So how many joints we have? So 4 joints we have, and how many then? 3 revolute plus 1 prismatic we have, and 3 revolute means 1 degree of freedom, we get 1 degree of freedom, plus 1, and the prismatic, so the prismatic again 1 degree of freedom. So Fi is equal to here 4, and I means here F4. Okay, and let us satisfy the equation. Okay, so we're going to satisfy the equation F is equal to 3, then 5 minus 4 minus 1 plus 4 is equal to what? 4 degrees of freedom. Okay, so it is an open kinematic chain serial manipulator. So just by the visualization also we can see how many joints are there, and each joint imparts 1 degree of freedom in the case of robotics, depending upon the joints. Okay, like prismatic joint 1 degree of freedom, revolute 1 degree of freedom, and suppose spherical, then 3 degree of freedom. Okay, so in this way we have done this problem. And what about the another problem? So with this, thank you. In the next lecture we will do some another problems, 1-2 problems.